So today we're going over 6.5, graphing linear inequalities in two variables. So our objective today is to graph and solve linear inequalities in two variables. So let's refresh a little bit from before. How do we graph an inequality, and how do we rearrange an equation to graph? When you graph an inequality, guys, you can graph them just as if they were an equation. So if you can think of it as x is equal to -5. If you guys remember, that's going to be a line right here, right, for x equals to -5. A little more straight than that. Now, how do we graph this? There's two things that you need to know. If it's greater than or less than, the line is going to be dotted like this. If it's greater than or equal to or less than or equal to, then the line is going to be solid. The whole difference is if you have the solid line at the bottom, it's going to be solid. If you do not have the solid line at the bottom, it's not going to be solid. So following that, we notice that this one is going to be dotted because it is a greater than. So again, we're going to go at -5 and just draw a dotted vertical line, just as if it were an equation. Now, how do we know how to shade or where to shade? Because when we're graphing inequalities, we have to shade the answer. Because again, it's going to be any number bigger than -5 on the x. So if we look at the x, we're going to notice that it's going to be any number greater than on the x. So if we look at the line right here, the numbers that are greater than are going to be to the right. So that is the side we're going to shade. We're going to shade everything on the right of that inequality because that is where the x is bigger. Now let's do the y in red. So we have the equal to at the bottom, so it's going to be a solid line. Y is equal to 0. It's going to be a line right here, a horizontal line. Again, you can think of it as y is equal to 0 when drawing it. Now, how do we know what to shade? We're going to shade, again, they're asking for the y when it's less than or equal to 0. So we're going to look at the y. When is the y smaller than 0? When we're going down from where our line is. So we're going to end up shading everything underneath that horizontal line. The key is realizing which way. It's based on the, what's the word? It's based on the axis. So if it tells you x is greater than -5, you're going to look at the x-axis and see, okay, this is -5. This is where my line is. I'm going to see which way is greater. So it's going to be to the right as we drew with the black highlighter. If we look at the y for the second equation, it's telling us y is less than or equal to 0. We can think of it as y is equal to 0. Because it has that solid line at the bottom, we're going to draw a solid line at y is equal to 0, and we're going to look at the y-axis. Since it's saying y is less than or equal to 0, when is y is less than or equal to 0, we look at the y-axis under that line, so that's the way we're going to shade. That's how we're going to graph those inequalities. Now, for number 3, they want us to write -6x plus 2y equals -4 in slope-intercept form and then graph it. Remember, slope-intercept form is y equals mx plus b. So I'm going to go ahead and rearrange it. I'm going to go ahead and add the 6x on both sides. To get 2y is equal to 6x minus 4. Now, we're not done because the y is not by itself. So I'm going to go ahead and divide everything by -2. So it's going to cancel out on the left to get y is equal 6 over 2x minus 4 over 2. That's going to simplify into y is equal 3x minus 2. Now, I'm going to go ahead and graph it. This is a line. It's not an inequality, so there is no shading involved. The difference between the inequality and the line is that the line is not shaded and the inequality is. So when we graph it, we're going to start right here at -2. We're going to go up 3. So 1, 2, 3, and 1 to the right. 1, 2, 3, and 1 to the right. Now, this is a guesstimate of how to draw this. because I can't really draw that great straight lines. But that would be our blue line graphed. Now again, important, inequality we shade, equation we do not shade. So I'm going to write that. Inequality we shade. And then up here, I guess. Equation do not shade. That is really important. Again, you can think of this as graphing it as an equation, but just remember, if it's less than or greater than, dot it. If it's less than or equal to and greater than or equal to, solid line because of that solid line at the bottom. So a linear inequality is similar to a linear equation, but the equal sign is replaced with an inequality symbol. And a solution of a linear inequality is any order pair that makes the inequality true. So I'm just going to redraw the graph from before of x is equal to negative, or x is greater than -5. So we have this line right here. Again, this is just a ish drawing of what's going on the previous example. Right? So this is what we have. Like I said, a linear inequality is similar to a linear equation because you graph it the exact same way. Except instead of an equal sign, we have an inequality. And we graph it depending on if it's greater than or equal to, or if it's greater than by itself. In this case, it's by itself, so it's dotted. And the solution is to the linear inequality is any order pair that makes the inequality true. So what does that mean? All of this shaded in red right here, all of those are solutions, okay? So this dot right here is a solution, this dot right here is a solution, this dot right here is a solution, this one right here is a solution. All of these are solutions. As long as the x is bigger, it's a solution to the inequality. Now the moment, because it does not have the equal to at the bottom, our x touches -5 or goes to the left, that is no longer a solution. So no longer a solution. All of everything to the right of the line is a solution because makes any of those points are going to be, the x is going to be greater than -5. We're going to do more examples. It's going to make a little more sense as we move on. But I want you guys to get the grasp on it. If we had x is greater than or equal to -5, for example, we're going to have a straight solid line. So when we graph this, all of these points, just like before, all of these are solutions, including the one at -5, because of this equal sign at the bottom. So all of these from the line onwards are solutions. The moment the dot is on the left side as -5 or bigger, so it's bigger than -5, then that's no longer a solution. So here, let's tell whether the order pair is a solution of the inequality. So you can do it different ways. You can plug in if they give you a point, or you can graph it. In this case, let's plug it in. So we're going to graph this order pair right here and plug it into the equation. So I'm going to plug in the -1, which is our x, and the 9, which is our y. So I'm going to get 2 times -1 plus 9 is less than -3. So when I do that, I get -2 plus 9 is less than -3. That's going to give me that 7 is less than -3. Now, since 7 is not less than -3, this order pair is not a solution. Okay? Now let's do the same thing for the other equation. We're going to plug in our x, which is a 2, and our y, which is our -2. We're going to plug it in to 2 minus 3 times -2 are greater than or equal to 8. So we get 2 plus 6 is greater than or equal to 8. We get 8 is greater than or equal to 8. Now, because we have the equal to part at the bottom, the 8 is a solution. So this time, yes, it's a solution. Just so you guys see how it would look like if it's not a solution. So let's write this exact equation. but without the equal to at the bottom. We're going to plug in the exact same order pair. So we get 2 minus 3 times negative 2 is greater than 8. 2 plus 6 is greater than 8. We get 8 is greater than 8. Now, obviously, we get the exact same solution because we're using the exact same equation with the exact same points. But in this case, for the blue one, it's not a solution. The reason being, we don't have that equal to right here at the bottom. So that is very important to notice. If you guys don't see the little line at the bottom and it's the same number, it's not a solution. If you have the same number and you have the line, then it is a solution. So I want you guys to see both examples. As you can see, this one was very obvious because 7 is not less than negative 3. But it is important to note that that equal sign at the bottom of the inequality symbol is important. It does matter whether the answer is a solution or not. So graphing linear inequalities. The first step is to solve the inequality in slope-intercept form. So you guys remember, slope-intercept form is y equals mx plus b. The second is to graph the boundary lines using a solid for less than or equal to or greater than or equal to, and a dashed line or dotted line for less than or greater than symbols. Like I said, if it has an equal sign, the solid line at the bottom, it's a solid line. If it doesn't, it's a dotted line. That just means the solid, the answer is included, and the dotted is not. You guys remember when we were graphing in number lines at the beginning of the year? If we had a line at the bottom, it was a solid dot. And if we didn't, it was an open dot. This is when we were doing number lines. The exact same idea happens right here. Solid means it's included, dotted is not. For step 3, we want to shade the half plane above the line y is greater than or y is greater than or equal to. Shade the half plane below if it's y is less than or y is less than or equal to. You can check your answer by choosing any points on the graph and plugging them in. But like I said, guys, in this case, it's a y. So when you're looking at the y, you want to make sure when you're graphing this line or this one, you shade up because the y has to be bigger. And if it were to be these two, you want to shade down, assuming it's the exact same line, because it's telling us that the y is less. So when the inequality is written as y is less than or equal to or y is greater than or equal to, the points on the boundary lines are solutions to the inequality of the line is solid. So what I was telling you guys, if you have the solid at the bottom, the answer is included. If it doesn't, then it's not included. So when we look at this one now, we read this one already. Let's read this one. When the inequality is written as y is greater than or y is greater than or equal to, the points above the boundary line are solutions to the inequality. So notice how in both of these cases, the y is bigger, and notice how the y gets bigger. Even if the line is slanted, we still go from where the point crosses upward, because that's where the y is going to be bigger than our line. Okay, does that make sense? And then let's read the following. Let me erase this so you guys see it. Now looking at the following, when the inequality is written as y is less than or y is greater than, we're going to have the points of the boundary line are not a solution. So again, a dotted line, solution of the inequality, and the line is dashed. They keep saying dash, I keep saying dotted. It's the same thing. It's going to be a line that is not a straight, it's not a solid line. Now reading this one, when the inequality is written as y is less than or y is less than or equal to, the points below the boundary are the solution to the inequality. Y below. Notice how they're saying that the y is less. And right here, the y's keeps becoming smaller and smaller because they are based on the axis. So let's go ahead and graph the solution of the linear inequality. We have y is less than or equal to 2x minus 3. So again, the first step is to, the inequality is already solved for in y. I was going to say to solve for it in slope-intercept form, which is y equals mx plus b. since it's already solved for us in slope-intercept form, I can just go ahead and graph it like I usually would if it were an equation. Put a point right here at -3. I'm going to go 2 up and 1 to the right, 2 up and 1 to the right. Oh wait, I went 3 up. Let me fix that. Now, I'm going to draw the line. But before I draw the line, I want to make sure that it's either going to be dotted or solid. Looking at the equation, I have the equal to at the bottom. So I'm going to go ahead and do a solid line to the best of my abilities. Now, which way do I shade? It's telling me that y is going to be less than that equation. Since y is less than, I look at the axis and I notice that less than is going to be down as the y's become smaller as I move down into the axis. A great point of reference is where the y-intercept is. So we can look at the points from -3. When does -3 become smaller? When we go down from there. So that's the way you want to shade. I always do it based on that point instead of a random point in the line, as sometimes it makes it a bit harder, but it is the same thing at the end. Whether I look at it from this point or this point or this point, it's always going to be down as the y is going to become smaller. So you're still shading the same area of the equation. Now keep in mind, in this case, since the line is solid, the answer is included. Doesn't have to be a perfect shade, guys. A lot of the times when I was taking tests, I used to just do this to kind of mark it, or just do like lines like this. There's some points that you're going to see that they're going to match, so it's going to matter to make a difference. But right now I'm just using it as a highlighter, so it makes it a lot easier to see. Now, I want you guys to understand how to check. I'm not going to test you on checking it, but it is good to know. So I'm just going to grab this point right here, 5, 0. 5, 0 is a point inside of the shaded area. That's a great way of choosing. Just choose a point that's easy to solve for, that's shaded, okay? So when we do that, let's plug it in. So our y is 0 and our x is 5. So 0 is less than or equal to 2 times 5 minus 3. So I get 0 is less than or equal to 10 minus 3. So I get 0 is less than or equal to 7. Now, because 0 is less than or equal to 7, we know we chose, or we shaded the correct way. Because that is correct. That is a true statement. 0 is less than or equal to 7. So, to graph y is less than or equal to 2 in a coordinate plane, I'm going to notice it's going to be a horizontal line. Now, it's going to be a horizontal line where y is equal to 2. I notice this has a solid line at the bottom, so I'm going to go ahead and draw a solid line as my inequality. Now, they're telling us that the y is going to be less than -2. So from that point of the y-intercept, the way the graph is going to look is going to be shaded downwards. I'm going to go ahead and just shade it. That's good enough. So that's how you're going to graph it. Now, how do you know if you graphed it the right way? You choose a point. I'm going to choose the point 0, 0 because it's in the shaded area. Our x is 0 and our y is 0. Now, there is absolutely no x to plug into, so I'm just going to plug the y. So 0 is less than or equal to 2. That is a true statement, so you know you shaded the correct way. You could have chosen any point on this graph, including something on the line. I would never recommend you doing anything on the line because you're working on your shading on anything on the line. The line, you're going to know it's either solid or dotted based on the inequality symbol, whether it has the equal to at the bottom or not. But I would never recommend you checking the point with the line. Check the point on the shaded area. Now, You're going to have time to do this one on your own. I just want to practice with you guys how to rearrange it. The first thing we're going to do is add the x on both sides. So we're left with 2y is greater than x plus 2. I will divide by 2 on both sides. So I get y is equal to 1 over 2x. Plus, this is going to be 2 over 2, which is going to simplify to 1. So plus 1. So I don't know why I wrote equal. So it's y is greater than 1 over 2x plus 1. This is what you guys are going to be graphing. So the first thing I'm going to do is graph the first point, the y-intercept at 1. And then I have a slope of 1 over 2, so we rise 1 and we run 2. Now, since I'm not on Notability, I will be doing a bunch of dots, just so it makes it easier to graph. Since I don't have the straight line feature that you guys do. Now, I have all the dots for that line to make it easier for graph for me. As long as you put 1 or 2 or 3 points, you should be fine. Now, before I draw the line, I want to make sure it's either going to be solid or dotted. So looking at the equation y is greater than a half x plus 1, I'm going to notice that it doesn't have the equal to at the bottom of the inequality, so it's going to be a dotted line. It's going to look something like this. Again, just dotted. As long as it's not connected, you guys are good. Now, the second thing I'm going to do is notice, well, they're saying y is greater than. So we want to make sure y is bigger. So look, going from the y-intercept, which is always my best point of reference, I notice the y's become bigger as we move up. So I'm going to go ahead and shade upwards of that line. Now, how do we check? Choose a point inside of the shaded area. I'm going to choose the point 0, 3 because I can. It's in the shaded area. And it's a very easy point as it's in one of them is 0. So when I plug in, this is my x, this is my y. Get 3 is greater than a half times 0 plus 1. Anything times 0 is just 0, so we're going to get 3 is greater than 0 plus 1. So we're going to get that 3 is greater than 1. Because 3 is bigger than 1, or greater than 1, we know that this is going to be a solution. So you know you graphed it and shaded the right way. So for this one, they want us to graph the solutions of the inequality, of a linear inequality. Now, everything we're working with, it's going to be a linear inequality so far. So don't get frustrated or get caught on the linear inequality. The first thing I'm going to do is help you guys rearrange it. So I'm going to subtract the 5x on both sides. And I'm going to be left with 2y is greater than negative 5x minus 8. I will divide by 2 everything. So I get y is greater than negative 5 over 2x minus 4. That's what we're going to graph. I'll give you guys a minute to graph it. So let's start by plotting the y-intercept at negative 4. Then it's a negative 5 over 2 slope. So I'm going to go down 5 and 2 to the right, or up 5 and 2 to the left. Okay. Again, since I don't have the straight line feature because I'm not in mobility, that's why I drew more points. As long as you do 2 or 3, you'll be fine. Now I'm going to go ahead and graph this line. Looking at the inequality, I notice is greater than. There's no equal to at the bottom, so I'm going to go ahead and draw a dotted line. So after I draw a dotted line, I'm going to go based off of the y-intercept, and notice that they're telling us that y is greater than, so we want y to be bigger, so we're going to go up from there. Now, then, since I'm going up from that point, I'm just going to shade everything that's included right there. Now, again, just choose a random point to check. You're not going to be tested on whether you know how to check or not. I'm going to go ahead and plug this point in, 2, 0. That is your x and your y. Again, as long as it's in the shaded region, choose whichever point you think is best. But I recommend you choosing a point that makes sense. So when I plug in the y, I get 0 is greater than negative 5 over 2 times 2 minus 4. What do I mean by a point that makes sense? I chose 2, 0 this time not at random, but because the 2's cancel out when I multiply this. So I'm left with 0 is greater than negative 5 minus 4. So I'm left with 0 is greater than negative 9. 0 is greater than negative 9, so therefore this equation is correct. And we shaded the region correctly. So for this problem, the first step, so you guys remember, is to put it in slope-intercept form. So that's y equals mx plus b. Now, in order to do that, I'm going to go ahead and subtract. There's 2 ways you can do this. I'm going to do it the first way. I'm going to subtract the 2 first. So minus 2 minus 2. So we get 4x minus y is less than or equal to negative 2. I'm going to subtract 4x on both sides. I'm going to get negative y is less than or equal to negative 4x minus 2. Now remember, you want the y to be positive, so I'm going to divide everything by negative 1. And if you guys remember from when we did inequalities at the beginning of the year, that means the inequality symbol is going to flip. So we're left with y is greater than or equal to 4x plus 2. This is one way of doing it. Now the second way of doing it is if you just add the y. If you just add the y to both sides, you're left with 4x plus 2 is less than or equal to y. When you rewrite it with the y on the left, we end up with the exact same thing as before. So you can choose whichever way you'd rather draw it or solve it. Just make sure you follow the rules for inequalities. Now, in order to grab this, I'm going to go ahead and plug the first point at 2. And then I'm going to do 4 points up. So 1, 2, 3, 4, and 1 to the right to do rise over run. And since I'm not using notability, I'm popping a few more points than usual. You don't have to, because notability lets you draw a straight line. In this case, I'm not using it, so I need to have a little bit more guidance on what's going on. Now, after I draw the point, that is my boundary. I'm going to look if my boundary is going to be solid or dotted. In this case, it's going to be solid because we have the or equal part at the bottom of the inequality. So I'm going to go ahead and draw this line as best as I can. And afterwards, you're going to notice that is saying that y is greater than in both cases. So going from the y-intercept, which is always my the best point of reference, or one of the best points of reference, the y gets bigger as we move up. Now that means that we're going to fill in everything to the left of that line. And the line is included, the boundary. Now, the way you would check it, guys, I'm going to just choose a random dot. I'm going to choose, let's say, negative 3, 0 to check. So I'm going to plug it in. I'm going to get 4 times negative 3 minus 0 plus 2 is less than or equal to 0. When I multiply the 4 times negative 3, it's going to get negative 12. Plus 2 is less than or equal to 0. When I simplify that, I'm going to get negative 10 is less than or equal to 0. Seeing that it works, we know we shaded the correct section. Here, they want us to write an inequality that represents this graph. Now, the first thing you want to look for when you're writing the inequalities yourselves are for the y-intercept and the slope. Now, looking at this line, our y-intercept is right here at 0, so I'm just going to write 0. And the slope is going to be down 1 to the right. So we're going to have a slope of negative 1. So we write an equation the same way we usually would for if we were to write an equation. So it's going to be y equals mx plus b. But instead of the equal sign, we're going to write an inequality. But first, let's write the equation. So by writing the equation, I get y equals, the slope is negative 1, so negative x plus 0. Now, we don't have to write the 0. You can write y equals negative x, and that's fine. Now, you are almost done writing this. Now, you're going to look at where the shaded area is. So from the y-intercept, we notice a shade shaded down, so our y is actually becoming smaller. Because our y is becoming smaller as we shade, we're going to actually end up with y is less than negative x. Now, if it's going to be dotted, which is the case, in this case it is, we're done here because we don't have to write or equal at the bottom. If this were a straight line, we would write less than or equal to negative x. So following the previous example, I'm going to write the information I want to find first, so the y-intercept and the slope, or the m. I'm going to write m and then slope, so we have it. Usually with the m, it's just enough. Now, our y-intercept is right here at negative 3. And our slope, we actually end up going up twice and one to the left. So we rise 2, and we run negative 1, so 1 to the left. So it's going to give us a slope of negative 2. Now, since we want to write it in the slope-intercept form, y equals mx plus b, I'm going to start and go ahead and do y equals negative 2x minus 3. And now I'm going to change the equal sign to an inequality. So y, I'm going to leave the space, negative 2x minus 3. Now, looking at the y-intercept like we've been doing, it's right here. We notice it's shaded upwards. So since we went up from that point, we notice the y's are actually getting bigger. So y is going to be greater than negative 2x minus 3. Now I'm going to look if it's a dotted or a solid line. So the boundary, it's a solid line. So I'm going to write the equal to at the bottom. Y is greater than or equal to negative 2x minus 3. So if there's no questions, guys, we just went over yesterday's classwork as well. You guys do have homework, and it is posted on Canvas. It's the second part of the homework / classwork that you had last night.